So good morning everyone. In this video I want to give a quick overview about the classical orders of architecture. So actually how to actually design like classic architecture. So the most important thing is about the proportion, as most of you probably already know. So when we look at these famous buildings like this Villa Rotonda, for example, from Palladio, here at the beginning I show like 3 examples of Palladio, and those 3 you can see they all look very magnificent but very different to each other, and they all have in common that they have the Greek classic orders as a base. So here in the Villa Rotonda you see it's displayed in the porticos like a temple porticos in the Ionic order, and here it's 2 orders like stacked over each other, and there's always a different design idea behind of each of these 3 buildings, right? But they're all based on the classical proportions. So if you want to do that correctly, and that's how also you can distinguish like what we call like kitsch architecture in China or Russia or whatever, these architects don't actually know how to do the classical orders, and it's actually not too difficult to do them. So this lecture is based on a book called The Classical Orders of Architecture of Robert Chitham. I think I used it in another lecture before, and he kind of summarized the different orders from different theorists like Serlio, Vignola, Palladio, and so on, and he draw the recommendations of those architects and kind of summarized and draw his own like perfect order. So here you see the differences, the classic Doric that we know already, the Ionic, and here the Corinthian, and he summarized it to this one. So this is kind of for me the a good summary how you can design classic architecture based on the correct proportion. So we always start with the lower diameter of the column, which is kind of here. I hope you can see my mouse. So it's always, this is the value 1. So this is where the column starts. And here in this one he also includes the Tuscan order, but the Roman Doric, so not the Greek Doric order. And besides the famous 3-1 Doric, Ionic, and Corinthian, he also adds a composite order, which is like composition of Corinthian and Ionic, but actually in my opinion it's more like a Corinthian with these volutes on the corner. And because it's the richest, you also design the entablature in the most representative way. But so the basic proportion, as I said, the Greek Doric order would be much shorter, and they started actually with a proportion like 1 to 3.5. So 1 always is the lower diameter, as I said, and then it's about the height of the column at first. So the Greeks started with 1 to 3.5 or 1 to 4, and then they become slimmer and slimmer. And here he draw the Roman Doric order. So this has already a height of 1 to 8. So here's the lower diameter, right? And then the column has a height 8. And the whole entablature has a height of 2 lower column diameters. And actually you see if you scale that, they're actually always the same. So the Ionic has like 1 to 9 in the height. And then the ideal form that he summarized from all wrong direction. From all those, he say, okay, that's an average like 1 to 9, right? This is a bit shorter here. Perrault and Serlio had it like very short. But if this is 1 to 9 and then the entablature is 2.25 lower diameter, that's actually again like 1/4. So you see like 2 out of 8 is 1/4, right? 25%. And also 2.25 out of 9 is 25%. And when you look on the Corinthian order, that's the most slim one. So 1 to 10. And then he suggests like 2.5 lower diameter on the top. That's actually like 25% again, right? And he always suggests like 30% for if you want to have this kind of base, you can add it and it makes it more slim, obviously. So he suggests like 3 lower diameter or 30% of the height. You can see here he make it like ideal. So the Corinthian has the 3 while the height is 10, and the Ionic 2.7 out of 9 is again 30%, and 2.4 out of 8 as well. So you could also say in other ways the column become like thicker the lower the order is, right? So the Corinthian is the slimmest, and you could also scale that and draw them all in the same height, then you will recognize that the column actually become thicker. Maybe I should have put that here as well, but it's not in his book of Robert Chitham, but actually I did that before in the architecture CAD program. You can just take that and scale them all to the same height, and then you will see the entablature is always pretty much similar. Of course, the proportion within the entablature is different, but entablature is this part on top here, right? And then the column will be just like thicker the lower the order is. And as I said, the Greek Doric is even thicker than that. So we have this one, and actually important to know is, I'm sure is this here, yeah, is here you can see the, as an example, the Doric order. Please, what many architects even like in Europe do wrong. So there is an entasis. That means the column will be like slimmer from the bottom to its peak, and usually it's around like between 10 and 20%. So, or an average you can say 15% slimmer. So when this is a lower diameter of 1, right, the measure 1, then this is like 85% of it. So let's say if this is like 40 centimeter, then this is, how much is 85 or 40 centimeter? Yeah, whatever. So you know what I mean, right? So this is slimmer, and then the entablature stands on the peak of this line here, on the slimmer one. So that means the corner of the entablature is actually not over the 0 point of the column, which is here, but it's like shifted inwards a bit. That makes it problematic if you want to stack them over each other, like the Colosseum in Rome, for example, has like all Doric, Ionic, and Corinthian stacked. So that makes it problematic because it becomes slimmer in every floor, like, and but you can solve this later by yeah, in the design of the building. This can be solved. And then often the base that he draws here is also used to get is at the same time. It's kind of merged with the column that is stacked over that one. So, but we will see that later. So, and then of course the three entablatures, they vary from which order ever you have. And then the next important thing is the distances between the columns. So there is not one totally correct one. As you can see, Vitruvius suggested different. Vitruvius is the important theorist, right? From actually, the only one is remained from the Roman empires. There were more, but he's the only one remained. So he gave them different names, while here, for example, I think this Systulos is 3 lower diameter. So if here this column is 1, then there are 2 in between, and here this is another one from the middle of 2 columns. That's how we calculate it. Is 3 lower diameter, and in this one, and this one he called oistulos, the one on the top right side, and which means like the most beautiful one. So he, I think this is 3.25 lower diameter distance between the centers of each column. That means there's a gap of 2.25 lower diameter between these 2 columns. So, and then it's get more wide and wide. So the aerostulos here is meant to be, I think this is 4 diastulos, and aerostulos I think even 5 lower diameter distance. That means this is so wide you can even drive with a car through it. And here we see the examples for the Tuscan and the Ionic order as well. Because they are more slim, then it looks more narrow. Also the distance is the same. And so what do we have here? And of course you can just put them next to each other, which is often done for, like, if it's a pilaster, if it's not a full column, so just like a relief on the wall indicating the forces, but not a real full or half column. Then often this is done, what's drawn here on the top left side, like I think he write 1.25 in between, but it's like nearly next to each other, right? And so the next thing is how to do the arc. So many buildings combine columns and arc. so here's, if you want to look into that detail, you can look in this book. So this is there are different ways. There's not one totally 100% correct one how to put the arc in, but as you see here, to make it look like harmonic, the Corinthian one has actually like two full circles in it, and you see the massive, how you say, the volume of the column become less the higher the order is. So the Tuscan order has the most thick, like voluminous columns siding the arc, right? And the higher the order that gets, so the Corinthian order has a more slim columns, and then the arc is more narrow. And this increases even if you like add these kind of bases. You see here, these bases are not there, and if you want to add them, then if you have a Corinthian order with a base, then the column already is very thin and like nearly disappear. So, but still, this is like sometimes done in architecture. We can find that. So there you have the main vocabulary, and here you can like add it together, right? And you will see, because the lower order, so you usually stack like a higher order over the lower. So not you will start with the Tuscan, then the Doric, or here it start with the Doric one and then the Ionic, and then you will put the Corinthian on top, or you start with the Ionic and then the Corinthian. We will see examples for that later. Sometimes they also just do two Corinthian over each other, so the highest order 2 times, but you will not put the Doric over the Ionic. And one reason is that they become slimmer, right? So here the Doric has the classical kind of normal proportion you can see here, and because this upper diameter is around 85% of the lower one, then the second column, important now, starts with the lower diameter of this 85%. So here is like 100% or diameter 1, and the lower diameter of the lower order. Then here we have 85, and then this has to be one straight line going through, and the upper column has a lower diameter then of 85%, because it's the upper one, upper one from lower. And then here this reach already, I think it will be like 72 or something percent. So 85 out of 85. I mean 85% multiply 85. So then this is like, I think 72 or something percent of this value 1. And if you have a third one, it become even slimmer. So that means otherwise it look weird. And sometimes this is a very common mistake too, if people don't know how to stack orders. And here on the left side you see them directly stacked, so just like the Ionic over the Doric. And here is added the base under the lower floor, and the base of the upper floor can be at the same time the balustrade for the lower floor. Or you can also keep the upper floor, if you have only one floor, the balustrade of the lower floor has the same height as like kind of what's the name, like the fence on the roof. What's the name for that? Like a balustrade on top of the building. So the base of the upper column is the balustrade of the lower floor. Yeah. So, and here more examples. What's in this slide? More examples how to stack them. And here you have already pretty much the system. And here we have examples like on the real house. So I mean, he kind of used this to indicate the actual proportion of a facade. So you see here the Ionic order indicates the height of these 2 floors. And then in the next slide, he just take the columns away. So you see already the proportion system. The proportions remain, and the columns are totally gone. So this is the idea of how to find the right proportion of these buildings. So knowing that, here the windows are also important. That you usually start with the highest window proportion 1 to 2 in the lower floor, and then the next one will be, I think, root of 3. This should be like the root of 3, which is 1, 2, 7, 3, 7 something. So the second floor has this kind of 1 here, and then root of 3 in the height. And the third floor classically has a root of 2, which is 1.4142 in the height. And the width is always the same, like value 1. And then this is square window on top. But you can also leave the 1 to root 3 away and do the 1 to root 2 on top of the 1 to 2 window. So, but the 1 to 2 is the most elegant. So this is often used for the first floor because it can function as a door as well. And then often the second floor is this one here, the 1 to root of 2, which is 1 in the width and 1.4142 in the height. So but the windows become shorter the higher the floor is, mostly, but yeah. And And this is the cover of that book where I took these diagrams out of. I mean, there are more books plenty of books about this, but I think this is the most clear and the best one. It's a British architect. I believe this book was written in 1980s, I think, if I'm right. And so this is a pretty good overview. Yeah, now knowing this one, we can look back on our buildings. So this is the Villa Rotonda again. What do we find? The Ionic order here, and this kind of temple-like front. So you have the height here of the 1 to 9 probably, and then tablature in Robert Chitham's wisdom should be 2.25 lower column diameter and the height. And you see here it goes around the whole building, so it proportions the whole building, same as, this is the wrong direction, same as in this slide, this and this. So here you see it proportions the whole building, and the upper floor here, by the way, is a square window. Here you have this 1 to 2 window, and here you have a squared one. The height of this kind of upper floor is given by the triangle height of the temple porticos here, and the basis under it, I think, is pretty freely chosen. Yeah. So, and we have this kind of Ionic porticos like 4 times around 4 facades, and you see here we have, it looks like even the oistulus, or a bit more slim. The distance between the columns and the middle one is a bit widened up to like emphasize the center. And looking on this one, you will see that this and the next building I showed are actually pretty similar in the system, because it shows the Doric order on the ground floor, and then, as I said before, the basis of the second order on top, which is here the Ionic one, is at the same time the balustrade on top of the Doric. So you don't stack a balustrade on the first floor and then a basis for the column on the second floor, but you just like merge that together. So the balustrade, let's say the head of the first floor, is at the same time the basis for the second floor. So here it's like a Ionic column, and he also designed the entablature pretty rich, more or less like the Corinthian in the suggestion of Chitham. And you even see he like make this kind of here like roundish. So this is a pretty representative entablature for the Ionic column, but he used it probably because it's also the closure of the whole building. So the Doric on the first floor has no base, right? It's this column here. Here's the lower diameter 1, which gives the proportion of the whole building. This should be 2 lower diameter, roughly, the entablature of the Doric one. And then we have this base, and this should be the height 1 to 9. But, as I said, this lower diameter probably has 85% of the lower one, because it has to match the upper diameter of the Doric one. So, and then we have the main gesims here, and then another balustrade on top closing the whole building, and have these nice figures on top that Palladio always does. And the third floor kind of has more or less nothing to do with that system for the lower two ones. Probably in the elevation it makes sense in the proportion, but anyway, it's more like stepping back, right? The third floor. Yeah, and then this typical what's called Palladio motif is in the center. So Palladio kind of, maybe he I don't know if he even invented it, but he is always connected with his name, so it's called like Palladio theme. This kind of arc in the middle, and then like a straight beam holding a small column. So you see here's a very small Ionic column like fit in, and it doesn't really have a real entablature, just an architrave here holding the arc. So this kind of straight and then arc and straight line arc, this is kind of this typical what they call Palladio motif. And you see at the corner it's a bit shortened to give it an end. So here the distance of the column to the wall is shorter, and then we have like 2 columns at the corner to close it, so to give it like an end theme, a corner theme. This is typical for classical architecture at all, to emphasize often the center, but here this is not done. It was done in the Rotonda villa to have risalit. We also do not have that here, but then to emphasize the corners to close the building, so to give it like a definite ending. So here is done by these 2 columns on the corner, and the more, how you say it, dense pushing of the column to the big one, and you also see these holes are left out. So here we have these holes giving the rhythm of the main facade, and at the corners they are missing. So this is this corner theme, and you will see this is pretty similar if you look on the system. So you have also a Doric order on the first floor, same as here, and Ionic on the second. And the entablature is this one. It's not so elaborated as this one, and the balustrade on top is kind of left out in these gaps. So only the kind of base is left, which is a base for these figures on top, that makes this kind of this magnificent representative appearance. This is a private villa, by the way. Here this classical, this representative look comes from this risalit in the middle, which the other one doesn't have, and the emphasis of the center by pushing out this kind of, I think it's the main saloon here, and the kind of the main living room in the second floor, pushing it out and leaving the loggia on the sides and on the first floor completely. So this gives us this building this kind of typical look. But if you look on the system, as I said, it's pretty much the same proportion as this basilica. Of course, this one is longer, so it's the proportion of the whole facade. This is more long or flat. But the system of a Doric order is in the first floor, and the Ionic on the second is pretty much the same. And yeah, for closing, I show you a last building from the Baroque. So this is Borromini in Rome, a famous church. I can never pronounce the name of this church, but it's in the center of Rome. And here you see what I said before. He uses like maybe even 2 Corinthian, or this should be a composite, I don't know. But this is the Baroque is more free in its interpretation, right? But you see it is the same system. So here you see, hope you see my mouse, the basis for the lower column, and then this should be something like a Corinthian or fantasy Corinthian composite order. And you see here this entablature swinging fore and back. But then you also have entablature, then the basis of the second floor, at the same time the balustrade for the first floor, and another very representative order, which is even a more representative, Corinthian composite one, and a very elaborated entablature of the second floor, which is this one, right? And this is probably designed so richly because it's also the closure of the whole building. And then the balustrade on top, which is here. So it's actually in the vertical dimension the same system as that one. While this is a Renaissance building, right, from I think 1550 around, middle of 16th century, and this is a bit like around 100 years later. And you see, even this is like a very richly designed, free-designed facade from the Baroque. Is this the same system that I explained you at the beginning of the lecture? Yeah, thank you.